Alright, we are going to call this one, but Mr. Bowers, my data won't linearize. So this is really for those of you who are in the midst of your projectile motion lab and you're attempting to linearize that parabola and it just isn't having it. So I've created some data over here. This isn't real data, but it's near enough to get the point across. So I'm going to throw in this curve that you're looking at that is causing all of these troubles, right? So we want our time versus y. We're going to go ahead and insert a chart. And we want a scatter plot, if we could find that. There we go. Having trouble finding stuff on my... Let's zoom out a little bit. There we go. Insert. Alright, so here's our chart. Make it a little bit bigger. So you get this parabola, and it's like, great, it's a parabola. I know how to linearize a parabola. Let's change this name so we know what we're looking at here. This is y versus time, right? Our vertical position versus time. So there we go. That's done. Great. And we are going to get rid of that. We don't need that. Go away. Clear legend. Great. Okay. And can we send this guy? Change chart, advance edit. No, can't do it. Move to its own sheet. Alright. So we're going to stick that down there so we can find it. So we can go back to it. So we're going to linearize this thing. We of course know how to linearize data. We're going to go in here and we're going to insert a new row. We're going to say, great, what we need is time squared. We need time squared because this is a parabola, and that is how you linearize a parabola. So I go ahead and do that, equals that cell to the 2. There it is, and we go ahead and run that right down the line, and right down the line. We go ahead and select that. We go ahead and select our vertical data, and we insert a new chart, and we're like, oh yeah, we're getting there. This is going to work perfectly. And we go over here, and we grab our scatter plot, because that's what we want. And we insert it, and we say, what in the world is going on? That looks like a line, but what in the world is going on? This is not a line. Alright, well, so there's a little thing that was covered, but let's discuss it again. When we linearized a parabola, the assumption was that it was this picture. The assumption built in is that y is equal to kx squared, and maybe we've got plus b. That could be okay. We can actually handle that. However, that isn't what we have here. What we have in our original data, so to click over so you can actually see that, this thing, that doesn't look like that. What that looks like is this. We have y is equal to kx squared plus something else, call it c, whatever, cx plus b. Whatever, that's a nightmare, you don't write that. ax squared plus bx plus c. This is the form we have. And when we do our little trick here, so we let z be x squared, that's what we did, and we're like, okay, well then y is equal to az, that's good, there's our line right there, okay, but if z is x squared, then x is the square root of x? Or z, rather, no, hold on, where are my tools? Erase. Erase. Alright, so we gotta think about this one. So we need to replace x, not x squared, because we have an x right there. So x, yeah, x is the square root of z. Well, plus c. This is not a line. You know what that is? I'll show you what that is. That is this thing. That's what that equation looks like. So what are we going to do? I'll tell you what we're going to do. We're going to delete that. And we're going to go in here and we're going to delete this because that didn't work. What we are going to do instead is we're going to come over here and I need to fix this. Hold on a second, I'll be right back. Come over here, get rid of that. Do a little bit better with my chunk of screen that I'm capturing. There we go. Okay, now we can actually see what's happening. Alright, I'm going to come over here and I'm going to look at my y velocity data. Okay, because we know some stuff about y velocity and how we can get from velocity to position anyway. Okay, so let me illustrate what I'm talking about here if I pull this up. Alright, so I'm going to just clear this out. Don't save. Great. Alright, here's what I'm talking about. We know that position, in this case, what I'm saying is that the position is equal to, this part we know, 1/2 AT squared. But I'm saying in this case we have some other terms. Plus something times t plus something else that we'll just call b for lack of anything better to call it. Actually, we know what that is, so we don't have to call it that at all. We know this. We know that if we have a plus b, we know that it is initial position. Alright, so we have the position somewhere. This is the curve we're talking about. Well, here's what I'm going to do. I'm going to subtract initial position from both sides. So we have position, some position out there, minus the initial position is 1/2 AT squared plus something times t. This should look somewhat familiar. Some later position, some position that's out there somewhere, minus the initial position. Yeah, that's right. That's called displacement. That's displacement. So we're saying the displacement of our thing is 1/2 AT squared. We got that previously from our constant acceleration model. Plus something times t. Well, if only that were helpful. But we know something else too. This is also equal to the area under the VT graph. So let's look at that. We have this other piece of information, so let's go explore and see what we can find with that. So I'm going to come over here, take my times, take my velocities, going to insert a chart. We're going to give the internet its sweet time. I'm going to grab our scatter, we're going to insert that and change its name to VY versus T. And we're happy with that, and we're like, why are they giving us a... let's go ahead and shrink that up a little bit so we can actually see it. Alright, we get this nice linear velocity time graph, which should look really familiar because when you did this in the lab, you should have seen a linear velocity time graph. So with this linear velocity time graph, let's see if we can pull some information off of that idea. Let's just pick a spot. Let's pick a random spot. I'm going to transpose this over here. We have this graph. It's VT. Oop, 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 whoa. There we go. Vy against t, and it looks vaguely like this.